So now to the sweet stuff. You need to verify the parameters, right? So if you have the input data, the get data syscall from your assignment, and basically I input to it my name. It should not work. It should either, it should do what it is supposed to do. It should take either a user ID or a username. Okay, you can take a username, but if my username is not, if my name is not my username, let's put it that way. There are open things that were left for you specifically for your design, basically. But let's say that it takes user ID as a number, and then I input it with my name. It should fail. It should not basically break things, and it should just fail and tell you, oh, you shouldn't use that. So system call runs in kernel space, and you need to make sure that user parameters are, the submitted parameters are correct. And Linux provides you with some mechanisms to actually help you with this process. One of them is that if you want to write to user space from kernel space, you use copy to user function. That is defined actually over here. And that is basic. Oops, sorry. So that is defined over here, for example. And for reading from user space, it provides you also with another function, which is copy from user. Okay, so if you're reading from user space, this is what you use, and if you're writing to user space, this is what you use. And there are checks on this function. Of course, you should make extra checks if you need to, but getting input and providing output to user space, you should think about these two methods. And both of them would return the number of bytes they failed to copy on error. Okay, so how many bytes did that call fail? On success, they return 0. So let's look at this. Can you tell me what does silly copy do? If you just, so this is a system call definition that is called silly copy. Takes as input, has basically 3 inputs. Okay, so system call define 3 and does something. Can you basically tell me what it does? Okay, there is also a check so that because not all users are equal, so there is what we call a capable what is called capable function. And capable is to check if the caller is allowed to perform an action. We have not talked about users that much, but users can have different capabilities. There are normal users, like people on the normal, that have not been given higher privileges, and there are root users. And root users are basically super users that can interact with the kernel being less careful than it would be with a normal user. So capable is the function that you would use to basically check if the user is allowed to do this change. And for example, you basically have capable and between parentheses caps is nice. So can this user basically, or does this user have a capability to change the nice values of other processes? And Linux defines a lot of these capabilities that users can do, and then you can basically, the default case is that super users have all capabilities and non-root users have no capabilities. Okay, so this is the default value, and basically the capability flags that I'm talking about, they are all in this file. So let's look at, for example, the reboot syscall that I was talking about. And this is basically a call that does reboot. And you do not want any user to basically go into your terminal, into your computer and type reboot. So a guest user, for example, when you fire up Linux, you can get a guest user. You don't want that guest user to just go in and type reboot and then, ooh, it just rebooted my machine and I just lost 1 month of work that I forgot to save. So you check for this. Does that user have the power to reboot? And
the philosophy is that we only trust the super user with rebooting the system, and then you basically check if the user is capable of doing capsys boot, basically. Okay, and that's basically you can find these checks all over the Linux kernel.